Assalamualaikum. In this video, we will learn about the odd and even functions. So let's see what are the odd and even functions. So firstly, let's look at the concept of odd functions. So we say that the function fx is an odd function if f of a negative x will be equal to a negative of fx, but another function will be called as an even function if f of negative x will remain as f of x. So let's test this one. So how to test? So let's just put the variable x with negative x. We just replace the variable x with negative x. Suppose we have this one, f of negative x. So this will be a negative x to the power of 3. So we expand this one will become a negative of x to the power of 3. And we know that x to the power of 3 is actually an fx. So this part is an fx. So this can be written as a negative of fx. So we can say when f of negative x is equal to a negative of fx, therefore fx is an odd function. Alright, let's just test this one. So suppose we have this function. So we just replace the variable x with a negative x. Therefore we'll have a negative x 2 plus a negative x to the power of 2. Therefore we can factorize a negative there. So we'll have an x over 2 plus a negative x to the power of 2 will become a positive x squared. And this is actually an fx. Therefore we can have this as a negative of fx. So we can conclude that fx in this case is an odd function. But what about the even function? Alright, so when we replace this one, alright, so let's try to replace the variable x with negative x. Therefore we have an f of negative x. Therefore the variable x is now changed to a negative x. We have a square outside here. We plus with 10. So this one will become x squared plus with 10. Right, so we should see that this one as an fx because this is the same one as this. Therefore this is actually an fx. Since f of a negative x, all right, is not changed, meaning to say that it remains as the fx, right? So we have f of negative x is equal to fx. Therefore we can say that this function is an even function. All right, let's try this one. We have a f of negative x. So this is actually a negative x, a modulus of negative x. So this is actually a modulus of negative 1 multiplied with x. So this is actually a modulus of negative 1, a modulus of x. We know that a modulus of negative 1 is actually positive 1. Therefore we have a modulus x. Therefore this is actually an fx. So this function is an even function. Right, now let's just test this function, the given functions here. Are they even, odd, or neither? Right. So let's just test the first one, right? So we try to replace f of negative x. So we'll have an 2 over a negative x to the power of 2. This will become a 2 over negative x to the power of 2 will become a positive x squared. So this is actually equal to fx. So we can say that fx is an even function, right? This one as an even function. Right, let's try the second one. What if you have f of negative x here? So we have a negative x to the power of 3. This will become a negative, what do we call that one will become this one will become a negative of x to the power of 3. Alright, so this one will become a positive x to the power of 3. So a positive x to the power of 3 is actually right, or we can say that alright, this part is the fx, so this is fx, so this is fx, so we can say that okay, this is a negative of fx. So this, when we have fx, f of negative fx is equal to negative of fx, therefore this is an odd function. Alright, odd function. Let's try the third one here. Suppose we have this. Alright, so when we have f of negative x, so we will have 1 minus of negative 1, negative x, therefore we'll have a 1 plus with x. Can we make a relation between this and this? We cannot actually. So when we cannot say that we cannot say that it is actually equal to fx or a negative of fx. Therefore, it is neither odd nor even. All right, neither. All right. Now let's look at the fourth one here. Suppose we have this function. So we have a negative x here. So we'll have a negative of negative x to the power of 3. Divided by a negative x to the power of 2 plus 1. Now we simplify this one. This will give us a negative. That one will become right. So I just bring this a negative, right? This negative in front here, and I'll have a negative right, I'll have a negative x to the power of 3, right, when I expand this part, right, that one when I expand this one. Right now the one at the denominator will become x squared plus 1, right? So we should know that this is actually an fx, so this is actually written as a negative of fx, therefore this is an odd function. All right, now we want to see the concept of the symmetry. All right, so the symmetry, we should know that when the what we call the graph, the function is symmetry about x-axis. So suppose it is symmetry about x-axis, suppose it is something like this, right? So we should have this y and negative y here, all right, should be on this graph. Right, what about if it is symmetry about y-axis? So suppose it is symmetry about y-axis, so the value for negative x and x should be on this graph, right? So something like this. And if it is symmetry about the origin, therefore, you know, it should be what do we call it? If I have xy, so a negative xy should be there, right? Something like this. All right. Now we have to test for each function if they are symmetry about x-axis, on y-axis, or the origin. So let's try the example 5 here. So we need to test. If we want to test for about x-axis, so let's try about x-axis first. So about x-axis. To check on the about x-axis, we have to replace the variable y with negative y. So we have a negative y. This one will become x squared plus with 2. All right. So this is not the same as this one. So we cannot say this is not symmetry about the x-axis. All right. Let's check about the y-axis. So when it is about the y-axis, so we should replace the variable x with a negative x. So we have something y equal a negative x to the power of 2 plus with 2. So this is actually equal to y equal to x squared plus with 2. And this is go back to this original function. So we have this as a symmetry about the y-axis. In fact, when we draw these functions, all right, so we'll have something like this. Yes, but this is an y equal to x squared plus with 2. So it is actually symmetry about the y-axis. All right. Now to check whether it is actually symmetry about the origin. All right. So about the origin, so we have to replace the variable x with negative x and the variable y of negative y. Therefore, we have a negative y. This one will become a negative x squared plus with 2. So simplifying this will give us x squared plus with 2. So this is not the same as this one, right? Not going back to the original function. Therefore, it is not symmetry about the origin. All right, not symmetry. All right. Now let's go to example 6. Suppose we have to test for this. Actually, this is a circle, right? For the symmetry. So we have to suppose we want to check about the x-axis. All right, x-axis. Therefore, we have to replace the variable y with negative y. Therefore, we have something like x squared plus with a negative y squared equal to 9. So now we have x squared plus with y squared. This is actually equal to 9. Therefore, this going back to the original one. All right, this is the original function here. Sorry, not original equation here. So we can say that this is actually a symmetry about the x-axis. What about the y-axis? So let's check about the y-axis. So to check about the y-axis, therefore we have to check a negative x, variable x with negative x. Now we have a negative x squared plus with y squared is equal to 9. Therefore we have this one will become a positive x squared plus with y squared, which is equal to 9. And this actually going back to this original equation. Therefore we can say that this is actually symmetry about the y-axis. And what if we want to check about the origin? If it is it symmetry about the origin? Therefore we have to replace both variable x and y with negative x and negative y respectively. Therefore we'll have a negative x squared plus with a negative y squared. This one it will become a 9. Therefore we simplify this one, x squared plus y squared. This one will become 9. And this is actually going back to this what we call original equation here. Therefore we can say that it is actually a symmetry. And in fact, if we draw this circle, so we have the center at origin and the radius is 3. So we have something like this. So this is 3 and this is a negative 3. and this is 3, and this is a -3, and this is origin. So it is symmetry about the x-axis, about the y-axis, and also about the origin. All right, now because why we can say that it is actually what we call symmetry about the origin, because if we have xy here, we have a -x and -y here. All right, something like that. Right now we need to test this graph for the symmetry. All right, so it's this function, this equation is for the symmetry. So when we want to test about the, suppose we want to test about the x-axis, so we will replace a -y with y with -y, so we have a -y squared, which will become a y squared, which is equal to x. It is going back to the what do we call original equation here, therefore it is symmetry about the x-axis. But what about the y-axis? So about the y-axis, therefore we will have something like we have y squared, we replace the variable x with -x, so it is not going back to the, because we can't do anything here, we cannot do, so it is not equal to this one, therefore it is not symmetry, right? Not symmetry. Now what about the origin? When we have to check about the symmetry about the origin, therefore we have to replace both variable x and y with the -x and -y respectively, therefore we'll have something like -y squared. This one will become a -x, so simplifying this will become a -x. Y squared is equal to -x, so it is not going back to this initial equation, therefore it is not symmetry about the origin. We cannot say it is symmetry. All right, that's it. Right, let's look at the last example in this video. We have suppose this function, this equation. All right, so we have to check for the symmetry. Then we want to check about, suppose it is about the x-axis, therefore we'll have something like we replace a y with -y, x squared minus 5. All right, sorry, x to the power 4 minus 5. And in fact, if we want to write y, okay, this will change, because this will become a -x to the power 4 plus 5, and this is not going back to this. All right, so it is not symmetry about the x-axis. All right, what about the y-axis? About the y-axis, all right, so we have to replace the variable x with a -x, therefore we'll have y equal to -x to the power 4 minus 5. Simplifying this, we know that -x to the power 4 will become a +x to the power 4 minus 5. This one going back to the normal, the initial equation here, therefore we have it as a symmetry about the y-axis. All right. And about the origin, all right, we have to check about the origin, therefore we have to replace the variable x and y with -x and -y respectively. We have a -y and -x to the power of 4 minus 5. We have a -y, this one will become x to the power of 4 minus 5. And if you want to change, okay, I will write a -x to the power 4 plus 5. So this is not the same as this initial equation, therefore it is not symmetry. Right, so that's basically the odd even function and the test for symmetry about the origin, about the x-axis, and about the y-axis. Thank you for watching this video.